You are welcome to Science Tutorials with Eternity, the schoolboy. Today we are going to take a look at chemistry. We have a question here, and the question says 50 cm cube of a 0.8 m hydrochloric acid stock solution A is diluted to 500 cm cube to make solution B. 25 cm cube of solution B is then diluted to 750 cm cube to prepare solution C. 15 cm cube of a solution C is diluted to a liter or 1 liter to prepare solution D. Calculate I, concentration of solution D, II, pH and pOH of solution D. All right, let's continue. The answer. Before we can answer this question, I want to point out something. That from the question, the 0.8 m, remember this m is the molarity or mole per dm cube, m hydrochloric acid stock solution was diluted 3 times to get to 1 liter solution. Yes, this is the stock solution. 0.8, let me be using mole per dm cube. 0.8 mole per dm cube hydrochloric acid solution is the stock solution, and it's labeled solution A. From there, the first dilution was done by making it up to 500 cm cube to form solution B. Then the second dilution, 25 cm cube was taken from this first dilution, and they diluted it to 750 cm cube to prepare solution C. That is the second dilution that was done. Then the third dilution was done by taking 15 cm cube from this second dilution, which is solution B, solution C, and make it up to 1000 cm cube or 1 liter to prepare solution D. So there are 3 dilutions. Please, let's take note of that. Now, so from the question, 0.8 mole per dm cube hydrochloric acid stock solution was diluted 3 times to get to 1 liter solution. Now, there's something I want to point out. Irrespective of the number of times or number of dilutions or the volume of solvent or water in this case that was added to dilute a particular solution, the amount of the solute remains the same. So in 500 cm cube of solution A, 750 cm cube solution C, 50 cm cube solution A, 500 cm cube solution B, 750 cm cube solution C, no matter the volume, contains the same number of moles of hydrochloric acid. Do you know why? Because no extra hydrochloric acid was added. Neither was the hydrochloric acid lost. So it is the same amount of hydrochloric acid. In this case, in moles, because we are dealing with mole per dm cube. If you still convert it to mass, it will still be the same what? The same weight. So in this case now we are working with moles. So I want to bring about a particular relationship. Now, that's why I'm mentioning this. So irrespective of the number of dilutions, the amount of hydrochloric acid in moles in each of the dilutions remains the same or constant. So let N be the number of moles in each of the dilutions. So in each of the dilutions, N is equal to what? CV. Remember this relationship. The number of moles is equal to the molarity times what? Volume in dm cube. So N is equal to what? CV. So if in solution Na, number of moles in solution A is equal to number of moles in solution B is equal to number of moles in solution C, number of moles in solution what? D. And N is equal to CV. If that is the case, that means Ca, concentration of A, solution A, and the volume of B is equal to the product of concentration of solution A and volume of A is equal to the product of concentration of solution B and volume of B, which is also equal to product of concentration of solution C and the volume of C, which is also equal to concentration of solution D and the volume of D, because N is equal to the product of concentration times what? Volume. Remember, the concentration is in mole per dm cube and volume is in what? Dm cube. Now let's go. So, having established this relationship, let us now find the concentration. For us to, yes, we can compress this in a straight formula, but I want to break it down so that we understand what happened. I don't just want to, go and start using a compressed formula, because most of you may not understand. That's why I want to break it down step by step. So let's go to the first dilution. The first dilution, we have the volume is the one that we diluted solution A to solution what? B. So what happened there is that 50 cm cube of solution A, which is 0.8 mole per dm cube, was diluted to 500 cm cube. That means you keep adding water until you get to the volume of 500 cm cube. Let's go back to this formula. Remember, we can use CAVA is equal to what? CBVB to find the what? To find CB. So to find CB, CAVA is equal to what? CBVB. Now let's make CB the sort of formula. If you make CB the sort of formula, that means CB is now equal to CAVA over what? VB. Now, in this first dilution, the CA in the first dilution is what? 0.8 mole per dm cube. Remember. Now the VA is the volume of that solution A that was used, that was measured before dilution, which is 50 cm cube. See it here. Now see it here. 50 cm cube. So VA is equal to what? 50 cm cube. CA is equal to what? 0.8 mole per dm cube. Now VB is the volume of the solution B that was produced. That means having diluted solution A to produce a particular volume, which is 500 cm cube of solution B. So VB is the volume of that solution B produced. VB is the volume of that solution B produced. We are looking for what? CB. Now, having done that, you now arrive at CB is now equal to what? 0.8 mole per dm cube times 500 cm cube over what? Times 50 cm cube all over 500 cm cube. If you notice, I didn't bother converting the cm cube to dm cube because the other cm cube will cancel the cm cube. So no need wasting time trying to convert it because they will cancel each other. So having done that, we now arrive at what? 0.08 mole. Molarity or mole per watt dm cube. So the concentration of the solution B is 0.08 mole per dm cube. Now, remember that from solution B was also diluted to produce solution C. So if solution C was produced by diluting solution B, that means you can still use this relationship to find the concentration of solution C. So to find concentration of solution C, which is CC, CBVB is equal to what? CCVC. We decided to use this because we have already determined CB. So that's why we are using this. It's now equal to CBVB is equal to CCVC. I want to note something. If you watch, I put CBVB1. This is B or not A. I use CbVb1 here. I have a reason for using that. Listen, look at the question. Actually, Vb is the volume of solution B, and actually the volume of solution B is what? 500 cm cube. But look at the question. They didn't ask us to use that same. Had it been they say we should use this same volume, which is 500 cm cube, and dilute it to 750. This, I wouldn't have put this VB1. But they say that from the solution B you produced, 25 cm cube of it was taken. So I needed to put something else, attach something here to distinguish this volume that was taken from solution B from the actual volume of solution B that was produced. So that's why you are seeing CbVb1. So let's continue. So if CbVb1 is equal to CcVc, it then implies that Cc, you make Cc the subject of the formula, is now equal to what? CbVb1 over what? Vc. Now, remember, we have determined our Cb to be what? 0.08 mole per dm cube. This is where we got it. Then that Vb1 now is now 25 cm cube as against the initial volume that was produced, which is 500 cm cube. 25 cm cube was taken from it. That's why we are having Vb1, which is what? 25 cm cube. Cc is what we don't know. But Vc is having taken 25 cm cube. Vc is now the volume we diluted it to. This volume now is the volume of the new solution of hydrochloric acid, which is solution C produced. So Vc is equal to what? 750 cm cube. Now, having made this sort of formula, we now substitute all these things here, and we now arrive if you multiply and divide, you now arrive at that Cc is equal to what? 0.0267 mole per dm cube. This is the what? Concentration of this solution produced, solution C. Now, let's go to the last dilution, which will yield solution D. Now, to find the concentration of the solution D, the last solution, what do we now do? Since we have determined that of solution C, the concentration and volume of solution D, we know them, we can now use it. We already know the volume of D, the volume we diluted it to, which is 1 liter, that is 1000 cm cube. Since we know it, we can actually find the concentration of what? Solution D, which is CD, using this formula. Remember why I add 1. The same thing, the same reason we have in VB. Vc is the original volume of solution C produced, which is 750 cm cube. But Vc1 is now the volume of solution C that was taken and diluted to form solution D. So let's go. So Cc, we have gotten it here to be this. So Cc is equal to 0.00267 mole per dm cube. That Vc1, see it here, is the volume that was taken. So 15 cm cube of solution C was taken, and diluted. So that's why you are seeing that Vc1 is what? 15 cm cube. Now let's go. Cd, the concentration of solution D, we don't know. Then Vd, we know Vd to be what? 1 liter, which is taken as 1000 cm cube. We need to convert it to cm cube so that you can cancel this cm cube here. Now let's go. If that is the case, Cd is now equal to what? CcVc1 over what? Vd. If you put everything here, substitute everything here, you arrive at Cd is equal to what? 0.00004 mole per dm cube, which is 4 times 10 to the power of minus 5 mole per dm cube in exponential form, in exponential notation form. Therefore, the concentration of solution D is what? 4 times 10 to the power minus 5 mole, or simply mole per what? Dm cube. All right. Now, this is for this, the answer to question I. Now, let's go to question II. They say we should calculate the pH and the pOH of solution D. Remember, there's the relationship between hydrogen ion concentration and the log and pH. They say that pH of a solution is defined as negative log to base 10 of the hydrogen ion concentration. pH is defined as negative log to base 10 of hydrogen ion concentration. Now, how do we now find the hydrogen ion concentration in hydrochloric acid solution that has molarity of 4 times 10 to the power minus 5 mole per dm? How do we now find it? We now go back to the ionization of hydrochloric acid, not hydrogen chloride, sorry, hydrochloric acid, because hydrogen chloride is not electrovalent. It's not ionic, so it should be hydrochloric acid. If I mention hydrogen chloride, sorry, it's hydrochloric acid. Now, hydrochloric acid now, when ionized, will give what? Hydrogen ion plus what? Hydroxide ion. Now, if you look at this ionization now, that implies that one mole of hydrochloric acid will yield 1 mole of hydrogen ion and 1 mole of hydroxide ion. But you are dealing with concentration. Mole is just an amount. We are dealing with concentration, which is mole per dm cube. Now, since if the volume of the solution is constant, no volume was lost, is the same. The volume of the solution is constant. That means the concentration of hydrochloric acid here will also yield the same concentration of hydrogen ion and the same concentration of what? Hydroxide ion, because the volume is constant. And concentration is mass mole, number of mole over what? Volume in dm cube. So if that is the case, that implies that 4 times 10 to the power minus 5 mole per dm cube of hydrochloric acid will yield 4 times 10 to the power minus 5 mole per dm cube of hydrogen ion and the 4 times 10 to the power minus 5 mole per dm cube of hydroxide ion. That implies that the hydrogen ion concentration in this hydrochloric acid, that solution D, is 4 times 10 to the power minus 5 mole per watt dm cube, which implies that pH is equal to negative log to base 10 of 4 times 10 to the power minus 5. I decided to use logarithm to solve this so as to refresh our memory in the use of logarithm without using calculator. So let's go. I'll use this opportunity to refresh our memory on the laws of logarithm. Let's go, because almost all the laws are explained here. Now let's go. So if that's the case, this is now equal to this. Remember, there's law of logarithm that says that. Remember that there's law of logarithm that says that if you have log A, B, log C, log B raised to power C to base A. Okay, this one should use product law. We'll still get to this law. This law we use product law. Remember that law that said that log A B times C is certain as saying log B times C to base A is certain as saying log B to base A plus what? Log C to base A. This is the law. So remember the relationship, the operation here is multiplication. So that means minus will remain there, minus will be out. Bracket log 10, log 4 to base 10, which is this, plus log 3 to the power minus 5 to base 10. That is this law. So that's how we got this. You now come down again. That is when here now we now use this law that says that log B raised to power C to base 10 to base A is certain as saying C will now come back C times log B to base A. So log B raised to power C to base A is certain as saying C times log B to base A. That is what we have here. This is how we now simplify this. If we simplify this one now, this minus 5 will come here. That's why you hear minus 5 log to base 10, 10 to base 10. That's how we got this. Now, and there's also another law that says that any log of a number to its base, that is log b to base b, is equal to what? 1. Log of a number to its base is equal to 1. So because of that, log 10 to base 10 is equal to 1. That's why we change this to 1. We now have minus 5 times 1. This one is still there. Now, that's why we got this. Log minus is still there. Log 4 to base 10 plus minus 5 times 1. We now come again. We now come down again and open the bracket. If you open the bracket, you arrive at this level. That minus in bracket, minus is outside, log 4 to base 10 minus what? 5. Now, we now continue. If you open the bracket, this will multiply this. This will become what? Minus. This will become what? Plus. Because minus times minus is plus. So we now have minus log 4 to base 10 plus 5. Now, you rearrange it now. 5 will now come here because 5 is positive. 5 minus log 4 to base 10. Now, you now put this in index form. You now have 5 is equal to log 2 to base 10, log 2 raised to power 2 to base 10. We now employ this law again that says that log b raised to power c to base a is equal to what? C log b to base a. So we now that's why you now arrive at this, that 2 will now come here. We now have what? 5 minus 2 log 10 to base log 2 to base 10. Now, but remember that log 2 to base 10 is equal to 0.3010. So whenever we see log 2 to base 10, we put 0.3010. So we now have 5 minus 2 in bracket 0.3010. This will now open the bracket. We now have 5 minus 0.6020, which is 4. If you subtract it, you have 4.398, which is approximately 4.4. Now, that implies that the pH of solution D is 4.4. Now, but there is a relationship between pH and pOH. We say that pH plus pOH is equal to what? 14. Now, remember the pH scale, the highest there is 14. So if you add pH and pOH, the total will give you what? 14. So because of that, now we now make remember we are looking for pOH from the question. We now make pOH the subject of the formula, which is 14 minus pH, which is now 14 minus 4.4, because pH is 4.4. That means that pOH is what? 9.6. So if you add the pH and the pOH of a particular solution, they must give you 14. If they don't give 14, something is wrong somewhere. So that's why we now have pH plus 4.4 is equal to 4.4, while pOH is equal to what? 9.6. So if you add 9.6 and 4.4, you get to what? 14. So this is the answer to the question. Thank you very much for your attention. Please, if you have any question, feel free to chat me up through WhatsApp on the WhatsApp number on the screen. If you are interested, you can also be added. Let me know so I can add you in our WhatsApp group so you can be getting updates on our lectures. Feel free to watch other lectures and other edutaining videos on our YouTube channels. You can go to our company YouTube channel, Susan Limited. You can also go to our YouTube channel that is dedicated to purely educational videos. That is Susan Academy. You can also check my personal YouTube channel. That's where you see a lot of things, both educational, entertainment, other things, news, politics, anything that is worth posting and worth learning from. You see it there. The name is Fameternity the Schoolboy. That's my personal YouTube channel. My name is Fameternity the Schoolboy. See you next time. Please subscribe to our YouTube channels. God bless you.